Okay, so next thing I'd like to talk about is vertical asymptotes. So vertical asymptotes. So in precalculus, right, you probably have seen a definition of it. Basically, a vertical asymptote is a vertical line that the graph approaches but never crosses, and you probably have seen a definition that goes something like this. So let me just write it down. So if f of x approaches infinity, as x approaches some number c, then the line x equals c is a vertical asymptote. Okay, so let me give you just a quick picture. Right, so let's say there is right, so we have that, let's say this is our asymptote. That number here is 2. And the graph looks like this. Okay. So you see what's happening, right? So I have that x's are approaching number 2 from the left, and the value of the function just goes up towards infinity. Right? So that's the definition kind of from precalculus. So let me give you a definition that uses limits. Okay, so the definition looks like this. So if limit with x, where x approaches a, some number a, excuse me, of some function equals plus or minus infinity, and then limit with x approaching a from the left, okay, the same function, or add limit x approaching a from the right of f of x. It's missing something. Hold on. And equals plus or minus infinity, or limit with x approaching a from the right. So there's a plus right there of f of x also equals that. So either of those, right? Plus or minus infinity, and then the line x equals a is a vertical asymptote. Okay, so that's the definition. Let me give you an example. Maybe let's look at tangent function. Tangent function. Okay. Yeah, so let me graph it, and then we'll look at those limits. Okay, so tangent function has infinite number of asymptotes, and then they're at pi over 2, and then 3 pi over 2, 5 pi over 2. So this one should be here. Okay, so this one, so there is 4 between them, 4 units. Okay. All right, so this one is pi over 2. This one is 3 pi over 2. Negative pi over 2. And this one is negative 3 pi over 2. Okay, so that function, those branches of function, right, they go between those asymptotes. So that's the first one that goes through the origin. And then the shape is the same, it's just shifted, right? Okay, so that's the next one, and there is one more here. It should go, let me erase this one. It should go through the middle. Alright, so this value, and is negative pi. Right? And this value here, and this one actually goes through the middle. This value there is pi. Anyway, so yeah, the tangent function goes through. Right, so it has, for negative pi, tangent of negative pi is 0. Okay, so yeah, that function just keeps going to the left and right. And then there's another branch over here. Not gonna draw it. Okay, so let's write those limits. And so let's look at limits with x is approaching pi over 2. So when the limit with x approaching pi over 2, let's say from the right and then from the left. Okay, so from the right of tangent of x. Okay, so what is that pi over 2? Let's see. Okay, so we're approaching pi over 2 from the right. So pi over 2 is here. And we're getting closer and closer to it from the right. So we're moving this direction, right? Closer and closer. And when that is happening, the function just goes down towards negative infinity. Okay, so this is negative infinity. All right, so obviously that pi over 2 is a vertical asymptote. Okay, so let's look at limit with x approaching pi over 2 from the left. Alright, so from the left, pi over 2. Alright, so this time we're going this way. Right, approaching pi over 2. And if that is happening, our function and the branch, right, that branch that goes through the origin, goes towards positive infinity. Okay, so that pi over 2, or x equals pi over 2, is a vertical asymptote. Let's write it down. So x equals pi over 2 is a vertical asymptote. Okay. Yeah, so let me give you another example. Maybe this one is a little more complicated. So let me see. Did I call it an example? No, I did. Okay, so let's call this an example 2. Example 1. Sorry. So example 1. And what we need to do, let's take a function. Let f of x we make it bigger so that it's easier to write. So it looks like this, x squared. So it's a rational function, x squared minus 4x and then plus 3 is on the top, x squared minus 1 at the bottom. So we have the function, rational function, and what we need to do is determine. So let's find the limits. Determine the following limits. And find the vertical asymptotes. Okay, so we have the first one as limit with x approaching 1, f of x. And then the second, let's do, -1. So limit up, with x approaching -1. Let's do, from the right. So plus. And the last one, maybe I have space there. No, I don't. Okay, so we have limit with x approaching -1 from the left. Okay. Yeah, so let's look at that first thing. So I need to calculate limit with x approaching 1. Of the function. So that was something like x squared. What is it? Minus 4x plus 3 divided by x squared minus 1. So you can see that you can't really take that one, right? You can't plug it in because, you get division by 0. So that's something undefined. So the function is not defined for 1. But that doesn't mean we don't have a limit there, right? It just means the function is undefined. Because when we're calculating a limit, right, we don't care what's happening at that particular x. We care about what's happening next to that, or close, right? Close to that particular number. Anyway, so let's figure it out. So first thing, let's factor the top and the bottom. Right, so if we factor the top, we're looking for two numbers. When we add them, when we multiply them, 3. When we add them, -4. So looks like x minus 1, x minus 3. Okay, so that's the factored form of the numerator. And this one is easy, right? So x plus 1, x minus 1. Okay, so you see that we can, right? We have two factors. We can cancel them. And we simply get limit x approaching 1. The top is x minus 3. The bottom is x plus 1. Okay, so it looks like now we can plug in that one, right? So I can take this one, right, number, and put it in both places. Put it here, put it there, and we get, looks like negative 1. Okay, so the answer is -1. All right, so basically that's the limit, right? So when x's approach +1, the value of the function approaches -1. But that doesn't mean that that's the value of the function, right? It just means that that's the limit. All right, so we calculated that first limit, and we see that this is not that let's see, that x equals 1. This is not an asymptote. It's not an asymptote. Not a vertical asymptote. Well, why is that? Well, it's according to the definition, right? if this was to be an asymptote, right, we would need to have that limit equal to infinity, but it doesn't, right? It's not infinity, it's just -1. All right, so I don't know if you guys know what's happening at that one, but yeah, it's not an asymptote, and I'll show you in a moment what that is. Okay, so there was A, we need to do B and C. So B was, we're approaching -1 from the right first. So B, so we have limit x approaching -1 from the right. Okay, so the function is x squared minus 4x plus 3. And the bottom is x squared minus 1. And that's it. So, yeah, so the first thing we'll do the same thing, factor. And because we still, in this case, right, we can't plug in that -1 either, right? We can't take that -1 and plug it in here. So we need to do a little bit of work. Hold on, let me pause it. And so again, we have this simplified version. So we have limit with x approaching -1 from the right. The top was x minus 3. And the bottom is x plus 1. Okay, so the only tool that we have right now is our numerical method, right? So we can't do any algebra here, right, to simplify it more, and we still cannot plug in that -1 into the denominator. Okay, so let's try to figure out what that equals to using just plugging in numbers that are close to -1. So yeah, what numbers do we plug in? Let's see. Let's draw a number line. So this is 0, this is 1, and this is -1. All right, so we need to approach that -1 from the right. Okay, so that's what this plus means. Okay, so what we're going to be plugging in is numbers that are to the right of -1, that are close to that -1. So what could those numbers be, right? Could be negative. Let me use so for example -0.9, right? So it'd be a number close to this -1 to the right of it, -0.99. Okay, so if we do that, let me rewrite that function. So limit with x approaching -1 from the right. Okay, so the function is x minus 3, x plus 1. All right, so you see, if we're plugging numbers that are close to -1, right, this will be approaching this, so numerator approaches -4. Right, we could even say it is -4. Right, we could plug in that -1 into the numerator. It doesn't really matter. What is more important is what's happening with the denominator. Okay, so if we plug in numbers that are closer and closer to -1 from the right. Alright, so this denominator will be a positive number, so it's positive, and approaches 0. Okay, so if you, I don't know, if you want to check it, obviously, you can take the 0.9, or maybe something even like we could do. Let me put another number, negative 0.8. Right, so you can start plugging in all those numbers and see what's happening in the denominator. But you see that the denominator will be approaching 0, right? These will be positive numbers, right? Approaching 0, so getting smaller and smaller. This is a negative number, just negative, we can assume it's -4. So the whole thing, right, will be approaching negative infinity, right? So equals negative infinity. Okay, so that's what's happening. I'm just thinking about it. That's what's happening when I approach -1 from the right. Okay, so let's see what's happening if I approach that -1 from the left. Approaches -1 from the left. Alright, so we have x minus 3, x plus 1. Okay, so numerator doesn't really change, right? So numerator is going to be still -4. So numerator approaches -4. Okay, but then denominator is going to be different. All right, so now I'm approaching. Let me take a different color. See, now I erased everything. Okay, let's take yellow. All right, so now I'm approaching that -1 from the left. Okay, so the numbers could be negative 1.2, negative 1.1, negative 1.001, right? So closer and closer to that 1 from the left. All right, so when that is happening, you see that this is negative. So denominator is negative and approaches 0. All right, so this time I have, so this is negative, this is also negative, so the answer will be negative. The answer will be positive infinity. Okay. Right, so the conclusion is the function, the graph has a vertical asymptote that's at x equals -1. We have space here. So this was B, this was C, right? So the graph has a vertical asymptote. Vertical asymptote. At x equals -1. Okay. Yeah, so let me graph it. Let's graph it here. All right, so f of x what was that original function? Let's see, x squared minus 4x plus 3, I think, yeah. And the bottom is x squared minus 1. Okay. So maybe with white color, I'll graph that. How should we do it? Anyway, let's put that vertical asymptote here first. Okay, so this is it's not right. It should be a negative 1, right? Okay, so negative 1. So here. So this is negative 1. And how should we do it? What's the best way? So that you guys see it well and understand. Okay, so maybe with white or with blue color, let me try again. Okay, so something like this. Okay, so that's the left branch. And then the right branch is gonna be over here. Okay, that's pretty good. Right, so if I graphed something like this, and f of x, then the equation of this is not really what that original function is, right? So the equation of this would be that simplified version. So x minus 3 over x plus 1. Now what is the difference, right? The difference is that the actual graph, let's make it yellow, right? So this one, right? So this is the yellow graph. It's gonna be almost exactly the same with one little difference. Okay, so this is the left branch, and then and that actual graph is going to have a hole. Alright, so everything is the same except, and there's a hole at 1. So this is 1 right there, and it's a negative 1 right here. Okay, so the function is not defined for 1, right? Because if we plug in 1 over here, I get division by 0 and defined. So the function is not defined by for 1 and has a hole there, but the limit existed, right? So the limit is that negative 1. So you see what's happening, right? So if my x's, right, are going towards 1 from the from the right, my y's are approaching 1, negative 1, sorry. Now with x's approaching 1 from the left, right, same thing is happening. So that limit is negative 1. Let's write it. So limit x approaching 1 of that f of x equals negative 1. Okay, so yeah, I hope you understand what's going on. And yeah, let's do obviously another example. This one, actually, let's do let me give you a couple of problems for practice, actually. So let's do that. Okay, so practice. This is T, this is C, and this is E. Okay, first problem. Yeah, so find vertical asymptotes. Or holes right? So you need to figure out with something in the denominator, right? Zeros of the denominator, right? Basically is they're suspects, right? For holes or asymptotes. And let's put it a little bit lower. And the problems are, the first one is f of x equals x squared divided by x squared minus 4. Okay, so that's the first one. And then the other one is f of x equals x squared minus 1 x plus 1. Okay, yeah, so the answers are, for the first one, we have two vertical asymptotes, so, and no holes. And these are, and again, right, show work, prove it, show it. This one has a hole. Hole at x equals -1. Yeah, and maybe in that second problem, yeah, find that limit. Find the limit, right? So for this one, well, you will find it by just kind of by default, right? You need to find limit at x approaching. So you know, right, that in the first one, right? So you're finding two limits at x approaching 2 and -2. Here you're finding limits at x approaching -1. Okay, so this find the limit refers to this. Okay, just a reminder before we move on, right? So we did those two problems here, B and C. So I just want to emphasize that the fact that limit equals -infinity doesn't mean that there is a limit, that the limit exists, right? The limit doesn't exist at -1. And the same over here. Okay, but the limit exists here, right? For x approaching 1, right? So that limit is -1.